Hello, welcome to the FE Mechanical Preparation Exam. This is Chapter Electricity Practice Exam number 4. And the problem says that find the current that passes through the battery V1, that V1 it's this one. So, and they gave us 4 options, 2, 4, 6, and 8 amps. So the first thing what I'm going to do is to bring the equations that they are provided in the handbook, and let's see which equations I am going to use. So we have the Kirchhoff voltage law and the Kirchhoff current law, and also the Ohm's law. So basically what we need to do is that the Kirchhoff voltage law says that all the voltage that raises equals to all the voltage that drops. And basically, if we go around circuit, basically everything has to match the rises that drops. So we are going to call it this current I1. I'm going to call it this current that is in here I2, current 2. And then I'm going to have another current in here in this circuit that BE circuit is going to call it I3. So the other equation is the current Kirchhoff current law, that it says all the currents that goes to enters to a node equals to the currents that exit to the node. So basically what it says is that the currents that enter are equals to the currents that go out. So if we start from that equation, that it's the one that I think it's easy to understand. If we think about a node B, what enters? Enters I2 plus I3 equals I1. So we have one equation. And then the second equation is the first circuit on the left. If we start from node A, F, E, B, let's start from A. Well, what it enters, what is positive, sorry, and this is V1. And then the next one that we see is FE, that is the current R1. So this is negative because it's consumption. So everything that goes to the same direction of the current is and pass through a resistor is negative. So let's put R1 times I1. And then if we go to EB, we have the resistor R2 and the current I3. So it's going to be negative because it's going to in the same direction of the resistor when we move from E to B. So this is R2 times I3 equals 0. The next closed loop circuit is going to be BEDS. So if we go from BE, we have R2 I3 that is positive, so R2 I3, and then if we go around ED, there is nothing. VC, we have R3 times I2, so R3 times I2, negative, and negative because it goes in the same direction. We move where the current goes in the same direction. So basically we have 3 equations with 3 variables. We are going to put the numbers in here, so we are going to simplify the calculations. And then also we are going to rearrange the equation. So let's rearrange the equation like a matrix, yeah, all together. So first equation is I1 minus I2 minus I3 equals 0. Yep. The second equation is going to be, let's make some rearrangement. It's going to be R1, that is 6I1 plus R2 I3. It's R2 is 4, but it's in, this is 0 plus 4 I3 equals V1, that is 44. 2I2 plus R2 I3, that is R2 is 4 I3 equals 0. So basically we have these equations. That is the last equation that is going to give me 4I3 equals 2I2. And then if we remove the 2 and the 4, I would have, let's put it in here, 2I3 equals I2 equals I2. Let's do the, grab the two equations and let's put it in here. So I1, I cannot replace anything, minus I2, that is 2I3 minus I3 equals 0. Basically, I have I1 equals 3 I3. And if I grab the last equation that I'm going to put it in here, basically I'm going to rewrite equation 6I1 plus 4I3 equals 44. So what I need to find is the relationship between I1 and I3 and put this information in here. So let's continue. 6I1 plus 4I3 is I1 divided by 3 equals I3. So let's replace I3 by I1 divided by 3 equals 44. Now I don't like to use fractions, so let's not use fraction and let's convert this equation in different way. So let's multiply by 3. 3 times 6 is 18 I1 plus 4I1 equals 44 times 3, 132. So now I have 18 plus 4 is 22. I1 equals 132. I1 equals 132 divided by 22. And this is 6. So, and 6 is the answer C. So you can calculate I3 in here, and once you have I3, you can calculate I2 in here. So, and that's all. I hope these too many calculations, but once you define the problem with the correct equations, it's pretty straightforward. So thank you very much and stay tuned for more FE mechanical exam videos.